Hello, my name is Johan Hamstruva, and I'm a senior research fellow in the Behavioral Law and Economics group. The study I will present in this video is part of my habilitation project and explores a new procedural solution of a school choice problem. School choice, in the context of this project, refers to the question of how students should be assigned to schools. But note that school choice also encapsulates matching problems in general. What are good procedures to assign children to daycare institutions? How can we achieve a fair distribution of refugees over states? And how should we assign public housing to the disenfranchised? One commonality of these problems is that resources are scarce. For example, most schools only have a limited capacity of available seats. Even if the admissions criteria of a school are fair, and even if we allow students to express their preference rankings over schools, in most cases, it will be impossible to place each student at her first choice school and fully respect the admissions criteria at the same time. So what kind of admissions procedure should we use to solve the school choice problem? One prominent procedure used by several public school systems in the United States is the Deferred Acceptance algorithm, or Gale-Shapley mechanism. The basic idea of DA, as I will call it henceforth, is the following. If a student applies to a school and the school likes her, the student is only tentatively accepted at that school. If the school later receives an application from a student it likes better, then it may reject the tentatively accepted student in favor of the new applicant. Now, it is well known that this procedure has several virtues, but it also gives rise to a normative conflict between different procedural and outcome properties: strategy proofness, stability, and efficiency. What do these properties mean? Strategy proofness means that students have an incentive to rank schools according to their true preferences. Students can never improve their placement by misrepresenting their true preferences. They cannot game the admissions procedure. Strategy proofness thus creates a level playing field between sophisticated and non-sophisticated students. It serves as a protection of equality rights. This resonates with a recent decision of the German Constitutional Court in a university admissions case. According to the court, the placement of students should not entirely depend on how a student ranks at university. Stability means that the priorities of a student at a school are never violated. Suppose Bob is placed at school B and Alice at school A. If Bob prefers school A over his current placement at school B, the placement is only stable if Alice has a higher priority at school A than Bob. In legal terms, this means that the procedure fully respects the admissions criteria. Students and parents have fewer reasons to seek judicial review. Strategy proofness reduces litigation risks, and that's in part why US public school systems adopted DA. Efficiency, by contrast, only considers the choices of students. We can achieve efficiency by placing students at their first choice school whenever that's possible without making other students worse off, for example, by placing them at schools that they like less. Efficiency is legally relevant in that it makes sure that students' rights to choose a school are respected to the largest extent possible without harming others. Unfortunately, it is well known that DA is inefficient. So there is a conflict between stability and efficiency, and the question is, can we solve it? The most promising solution may be the efficiency-adjusted DA mechanism, EAAMO, a mechanism that was first envisioned by a co-author on this project. The basic idea of EAAMO is simple. EAAMO essentially tries to increase the efficiency of the stable matching produced by DA. In other words, EAAMO increases the probability of being assigned a first choice school without violating the priorities of students. This can be achieved by asking students whether they would like to waive priorities that do not affect their placement under DA. If students consent, Some schools are dropped from their preference list, but this will never harm consenting students. It can only improve the placement of other students. And if each student consents and submits a truthful preference ranking, EAAMO will produce an efficient matching. Now, EAAMO has remained mere theory so far, and that's why we designed an online experiment to address the following questions. First, does EAAMO really produce more efficient placements than DA? Second, how can consent rates under EAAMO be increased? Third, what is the impact of EAAMO on truth-telling? To explore these questions, we ran an incentivized online experiment with 500 participants. At the beginning of the experiment, each participant is randomly assigned a student role and a group. There are 5 students in each group and 5 schools with 1 seat available respectively. Each school has different priorities over students, and by design, each student has different preferences for schools. The screenshot you can see on this slide shows the decision problem that students face. Each student has to submit a preference ranking of schools. Each participant is randomly assigned to one of 4 treatment groups. DA serves as our baseline treatment. To identify the behavioral channels influencing the allocation in our school choice problem, we designed 3 different versions of EAAMO. A first one, in which consent requires an active decision, EAAMO consent. Consent is not automatic here. A second, in which consent is the default, and students can object, EAAMO object, consent is automatic here. And a third, in which consent is enforced, EAAMO enforced. Students have no freedom of choice and cannot dodge the waiver here. Let's turn to the results. The graph on this slide plots the average fraction of efficient placements in each treatment. As you can see, all EAAMO treatments do indeed strongly improve efficiency relative to DA. Moreover, we observe that EAAMO enforced yields the most efficient and EAAMO object the second most efficient placements. These results prompt 2 conclusions. First, EAAMO does indeed maximize placements at first choice schools, which should make students happier. Second, it is possible to further increase the efficiency of EAAMO by enforcing waivers or nudging users through defaults. The graph on this slide plots the average fraction of consenting students under EAAMO consent and EAAMO object. We observe that consent rates are higher under EAAMO object than under EAAMO consent, but this difference is relatively small and only marginally significant. What we can conclude from this is that consent rates alone are unlikely to explain the different efficiency rates between EAAMO consent and EAAMO object. In fact, this difference in our treatment effects more generally seem to be partly driven by students who attempt to manipulate the mechanism. The graph you can see here plots the average fraction of students ranking schools truthfully in each treatment. What we can see is quite surprising for 2 reasons. First, truth-telling rates are much lower under DA than in all EAAMO treatments. This is pretty much the opposite of what theory predicts, as DA is strategy-proof and EAAMO isn't. It may be that students incorrectly believe that DA is easier to manipulate. Second, under EAAMO, we observe the highest truth-telling rates in the consent treatment and the lowest in the enforced treatment. One potential driver is reactance. The more students feel constrained in their freedom of choice, the more they feel propelled to manipulate the mechanism. In sum, we identify a trade-off between the vulnerability to gaming and the efficiency of a mechanism. What can we learn from this? First, our project illustrates that fair distribution is neither simply a question of sound fundamental rights, nor is it just a philosophical question about the kind of fairness concepts that we wish for in a just society. It's also about the nitty-gritty of algorithmic design, and this question has remained a blind spot in legal scholarship so far. Second, Our project illustrates the importance of experimental and empirical evidence, not just to assess the effect of legal rules generally, but to identify normative conflicts. Some school choice mechanisms maximize the assignments to first choice schools, but the same mechanisms also have a downside as they seem to push students to manipulation, and this is likely to limit procedural fairness. Finally, we generate new evidence on how the placement of students can be improved without violating their priorities. As such, it may provide useful guidance to lawmakers keen on striking a fair balance between the right to choose and compliance with the admissions criteria. Thank you.